developed this XML-based notebook application. And you can see here the application is consisted of 3 Python programs. The first is the server side, which contains the main functions of the application. I have developed 5 functions. The first is add node, and then get node, delete node, delete one node, and wiki the information of the given search term and add the information to the given topic, and delete all the nodes on the given topic. And next program is the client side. This contains the user interfaces. And the next one is the test app, which is developed for testing if the system is able to handle multiple concurrent user inputs. And I'll first introduce the application and its functions, emphasizing how the remote procedure calls are made. And next, I'll explain how the failures and errors are handled. And finally, I'll explain how this solution addresses the design challenges of a distributed system. In our system, the client communicates with the server by sending HTTP requests. These requests contain information about the desired action, like adding a node, retrieving a node, and any necessary data required to complete the function, like the topic or the node function or node content. The requests and contents between the client and server are formatted as JSON file, and this allows for structured data exchange, making it more simple to transmit complex information such as node contents and error messages. Each function or operation supported by the server corresponds to a server's specific endpoint, like here, which is unique URL. For example, adding a node might have an endpoint like add node, and the get nodes function might have an endpoint of get nodes. When the client needs to perform an action, it sends a request to the appropriate endpoint on the server. When the client wants to perform an operation, it constructs an HTTP request with necessary parameters like the topic, the node name, and node text. And then this information will be packed to a dictionary and then to a JSON file, and will be sent as a post request to the server to complete the operation. And the request methods like the post or get for retrieving, post for adding to the server, and the endpoint URL are also specified. Once the server has processed the request, it sends back information, a response to the client, to indicate the client about whether this operation is successful or erroneous. If an error occurs, the response includes the error message to help the client to understand what went wrong. And I'll run this program to test its functions. Let's first run the server side. Run successfully, and next run the client side. Okay, let's first test the add function by typing add here. Let's take topic 1, name 1, text 1 as an example. And the return message is the node added successfully. Let's test by using the get function. The topic 1, which is the topic we've just added, and return information indicates that the node with the name 1 and content as text 1 and timestamp is successfully created. Let's test add another node under this topic, topic 1. Here's name 2 and text 2. And node added successfully. Let's get again. Topic 1. You can see that the next node with name 2 and text 2 is appended to the existing topic. And let's try the delete function. Let's delete topic 1, make 1, delete successfully, and let's get again topic 1. And you can see here the node with name 1 is deleted successfully. Let's test the wiki function, and let's try to add another information to the topic. Let's try to search Finland. And in this program, I've designed in such a way that the program will return the first 3 URLs in the Wikipedia that gets searched according to the given search term. And let's test if these 3 search terms and if the 3 results are added to the given topic. Topic 1. And you can see here, apart from the name 2 nodes we've just created, the 3 search results are also appended to the request to the topic. And let's test delete all function. The function aims to delete all the nodes on the given topic. Let's delete all the nodes on the topic 1 and delete it successfully. Let's get again to test if it works normally. Topic 1. And now the topic 1 does not exist because all the nodes under this topic are deleted. So this topic is equal to non-existence. And let's type this to exit the client interface. Let's try this test app program to test if the system is able to handle 5 concurrent inputs. And you can see the return information that all the 5 messages are added successfully to the topic concurrent test. And let's run the client side again to test if these 5 are added successfully. And you can see here, all the 5, or there are 10 because I've tried myself just once, all the 10 concurrent tests are added successfully, and these 5 are, you can see this 9 PM we've just added, so it passes the loading test. And here we can exit the function. And next I'll introduce how the failures are handled. Apart from the failures I've just showed you in the video, I've also handled other failures, including the non-existence of XML database file is here. If the database does not exist, an error will be raised. And the next is the non-existence of a given topic or a given name of the node is here. For error will be raised. And next is the handling the errors in Wikipedia API query, which is here. When the system's query of the Wikipedia of the given search terms fails, 500 error will be raised. And the last error we are handled in the program is the any unexpected errors, which means any unexpected errors other than those we've just stated will be classified into 500 and be raised. And last, I will introduce you how the system addresses the design challenges. For the heterogeneity, the server and client communicate over the HTTP using JSON, which is universally supported across different platforms. And this ensures that various heterogeneous components can interoperate seamlessly. As for openness, the server is defined with a clear API with endpoints for adding, retrieving, and deleting. And this allows for the addition or replacement of components without impacting the overall system. And for security, the way how the server validates requests and other operations are well protected from errors, and which may cause the crash of the entire system. These errors are protected from our system. And for scalability and failure handling, the Simple Flask server is able to handle